OpenAI is pushing its IPO back to 2027. Despite leading the AI boom, internal revenue misses and concerns over meeting public reporting standards have forced leadership to delay their market debut. This graph maps OpenAI's projected revenue targets against internal software adoption. While the financial projections remain flat, this steep exponential curve shows a 137 times increase in AI agent usage by non-developers over just 10 months. OpenAI's data proves that legal, recruiting, and support departments have fully absorbed these tools. These teams now use agents for daily automation and data transformation, moving the technology far beyond the engineering department. We are seeing massive acceleration in daily technical capability coexisting alongside hesitation about the business mechanics. The company building the tools is still struggling to price and package the future it is inventing. Look closely at the top 1% of those non-technical users. They are running multiple agents in parallel, generating more than 60 hours of compute time every 24 hours. A single person wielding that much parallel processing power matches the daily output of what used to be an entire department. These employees are now executing complex work entirely outside their original job descriptions. When one employee can deploy the equivalent of dozens of autonomous workers at once, managing the quality and safety of that output becomes nearly impossible for any traditional management structure to oversee. To manage these autonomous agents, the tech industry relies on a specific file format called AGENTS.md. It sits in a code repository and tells the AI what the project does and how to behave. But researchers at ETH Zurich just ran a controlled evaluation across models like Claude 4.5 and GPT 4.1 and found that these repository-level context files do not improve task success rates. In fact, they make things worse. Giving agents broad overview files causes them to explore unnecessary code and run pointless tests, driving inference costs up by over 20%. This 3D vector space visualizes how models process information. The blue line represents perfectly detecting bad behavior. The red line represents the lever to stop it, sitting 83 degrees apart. Models recognize mistakes, but because the control pathway is orthogonal, the steering lever is entirely disconnected. Grave. We have engineered systems with perfect internal hazard detection, while entirely missing the mathematical steering wheel required to control them. This lack of control gets magnified at the microscopic level by what researchers call a cliff token, a single hypercritical piece of data within an AI's reasoning chain. If a model generates a logic sequence and gets just one of these specific tokens incorrectly, the entire multi-step solution instantly collapses into failure. To reduce the massive expense of running these models, companies compress them into smaller, cheaper versions. But this compression process introduces a strange side effect. The models start to overthink. The compressed reasoning models generate up to 23% more text. They constantly second-guess their own logic in the intermediate steps, muttering "wait" and "alternatively" before frequently missing the correct answer altogether. By aggressively shrinking the models to save money, the industry is amplifying these chaotic reasoning errors and making the systems even harder to predict. Those inefficient overthinking models require immense physical infrastructure. These massive server farms are drawing so much power that hardware costs are spiking down the consumer electronics supply chain. The electricity demands are now heavy enough that AI data centers are re-architecting themselves to flex their consumption on demand, shifting compute to low-carbon windows to keep local power grids from buckling under the strain. Inside the office, the toll is structural. 70% of workplace learning happens by doing routine tasks. By handing those tasks over to autonomous agents, companies are quietly erasing the hidden apprenticeship that trains their junior employees. And when those agents make mistakes, the legal protections are disappearing. Security expert Bruce Schneier argues that companies must be held responsible for AI outputs, treating them as direct agents of the deployer. A German court has already set the precedent, ruling Google directly liable for the inaccurate information presented in its AI overviews. Unreliable AI behavior has transitioned from a technical glitch into a massive physical and legal liability. Our electrical grids and legal courts are now bearing the concrete costs of scaling a technology we do not fully control. Safety research is moving past output blocking and into the emerging science of model forensics, attempting to diagnose the model's internal brain before errors occur. This diagram illustrates a new technique from Anthropic. By injecting the simplest possible modification, a single rank 1 adapter, researchers can scan a model's internal parameters and map out exactly where genuine misalignment lives. Instead of waiting for a dangerous output, they can watch the learned parameters directly, isolating the exact narrow window of steps during training where a model undergoes a rapid phase transition into misalignment. The industrial rollout of artificial intelligence is moving far faster than our traditional safety guardrails. If we are going to deploy software that functions with the power of an entire workforce, we have to master this forensic science before the technology scales any further.